Hello everyone, welcome to a new lecture in the series of AI using Python. In this lecture, we will be discussing Recurrent Neural Network or RNN. RNNs are neural networks designed for processing sequential data such as audio, text, image, and time series data. The key elements of RNN which distinguish it from feed-forward neural network is the recurrent connection, which can be considered as a feedback connection. The recurrent connections enables RNN to capture time-dependent relations in the data and make them as a dynamic model. In RNNs, the data can be flow in both forward and backward directions, and the backward flow is through the recurrent connections, which are the feedback connections. Whereas in the case of feed-forward neural network, the data will flow only in the forward directions. The training data for RNN consists of input data which contains n observations of the input vectors and the output data which contains n observations of the output vectors. Then RNN computes the predicted output recursively as in this equation where FRNN represents the RNN function which uses the current value of the predicted output and the current input for predicting the next value. Here theta f contains all the parameters in the RNN which consist of weights and biases of all the layers in the RNN. Then the optimization problem for RNN is to find the optimal values of the parameters theta f, which minimizes the prediction error over the samples. The more general model of RNN contains some hidden variables as well, where the input is mapped into some hidden variables which are known as hidden states, and from states we will be mapping to the predicted output. This model will be a neural network which maps the input to an output through a hidden state HK, which plays the role of the memory. This architecture results in a state space kind of model, which can also be called as state space neural networks. Different variants of RNNs are introduced to deal with its shortcomings, such as vanishing gradient problem. This consists of long short-term memory network or LSTM network and gated recurrent unit or GRU. Next, we will be illustrating RNN using the MNIST dataset. First, we will be importing all the libraries. We can load the MNIST dataset, which is downloaded from this website. Then we can normalize the input values between 0 and 1 and also reshape the data for RNN. We can define the RNN model using the sequential function in the TensorFlow library. And here we can define the input shape and the neural network structure. Here we will be using softmax as the activation function. Once the model is defined, we can compile the model. And here we will be using the Adam as the optimizer and cross entropy as the loss function. We can train the RNN using the model.fit function with the training data XTR and YTR. And here also we will be using the number of epochs as 5. Since the RNN is a dynamic model, the training of RNN will also take more time compared to feed-forward neural network. And also it depends on the number of parameters in the model. Once the model is trained, we can evaluate the model by using model.evaluate function for the testing data. And here we can see that the loss function final value is like 0.14, which means the error is more compared to the CNN model. This depends on the number of parameters and the initial condition. And we can predict on a few test images and plot the response. So here we will be predicting for 10 images. And here we can see that for first one, the actual value was 7 and the predicted value is also 7. And for second one, the actual value was 2, predicted value is also 2. And here we can see that for all the 10 images, predicted value is the same as the actual value, which means the accuracy is good. That leads to the end of this lecture. Thanks for watching.